The United States embarked on its nuclear testing program in July 1945 with the historic detonation of the Trinity device in New Mexico. This event heralded the atomic age and the subsequent proliferation of nuclear technology and weapons testing. From 1945 to 1992, the U.S. conducted over 1,000 nuclear tests, positioning itself as the world's most prolific nuclear tester during this period. Initially, nuclear tests were carried out at remote locations such as the Pacific Proving Grounds in the Marshall Islands, particularly from 1946 to 1958. Notable operations included Crossroads, 1946, Ivy, 1952, and Castle Bravo, 1954. Operation Crossroads at Bikini Atoll marked the first series of post-war nuclear tests designed to investigate nuclear weapon effects on naval vessels, with two notable detonations, Able and Baker. The Baker detonation, conducted underwater, significantly contaminated the local environment, highlighting the destructive environmental consequences of nuclear testing. The Castle Bravo test, conducted on March 1, 1954, remains infamous due to its unexpectedly large yield of 15 megatons, significantly surpassing its anticipated yield of approximately 6 megatons. This miscalculation led to catastrophic radioactive contamination, affecting local populations, wildlife and ecosystems, and dispersing fallout far beyond the Marshall Islands. Radioactive ash from Castle Bravo fell on Rongelap and Utrik atolls, causing immediate radiation sickness among residents, who suffered nausea, skin lesions, hair loss, and long-term health issues such as cancer and birth defects. Beginning in 1951, the testing program expanded domestically at the Nevada Test Site, now Nevada National Security Site, located northwest of Las Vegas. The Nevada Test Site became the primary venue for nuclear detonations due to its remote desert landscape and perceived safety for testing. Between 1951 and 1962, numerous above-ground tests were conducted, notably under Operations Upshot Knothole, 1953, and Plumb Bob, 1957. These tests generated massive radioactive clouds that drifted extensively across the continental United States. The sizes of nuclear tests varied significantly, ranging from sub-kiloton tactical nuclear weapons to multi-megaton strategic thermonuclear weapons. Atmospheric detonations, visible hundreds of miles away, created mushroom clouds that ascended into the stratosphere, where prevailing winds dispersed radioactive fallout. Fallout included dangerous isotopes like iodine-131, cesium-137, strontium-90, plutonium isotopes, and americium-241, all with varying half-lives and toxicities. The fallout from atmospheric tests traveled vast distances. Tests conducted at the Nevada Test Site dispersed radioactive debris across the entire U.S., with measurable fallout detected as far away as New York, Vermont, and Maine. Fallout from Nevada was particularly severe in neighboring states such as Utah, Arizona, Idaho, and Wyoming, where the term Downwinders became synonymous with communities disproportionately affected by radioactive contamination. These populations experienced significantly elevated rates of thyroid cancer, leukemia, lymphoma, and congenital disabilities. Scientific studies confirmed radioactive fallout reached into agricultural areas, contaminating dairy products, vegetables, and livestock. Milk, in particular, became a major vector for iodine-131 exposure, disproportionately affecting children, whose thyroid glands absorb the isotope at higher rates, leading to significant long-term health complications. Throughout these tests, military and civilian subjects were used explicitly or implicitly to study the effects of radiation exposure. During Operation Upshot Knothole, troops were deliberately stationed close to the blast zones to observe psychological and physiological effects. Additionally, indigenous populations such as residents of the Marshall Islands became unintended subjects, suffering long-lasting health impacts from radioactive contamination. The Partial Test Ban Treaty of 1963 brought about an end to atmospheric testing due to rising global awareness and concerns about radioactive fallout. The treaty, signed by the US, the Soviet Union, and the United Kingdom, mandated that all nuclear tests be conducted underground to limit environmental contamination. Underground nuclear tests commenced at the Nevada Test Site, continuing until 1992. Fallout dispersal studies indicated that radioactive contamination from atmospheric tests was global, with measurable fallout recorded across Europe, Asia, and even Antarctica. Fallout particulates in the atmosphere circled the globe, entering ecosystems and food chains internationally, highlighting the global implications of nuclear testing. Radiation persistence varies significantly by isotope. Short-lived isotopes like iodine-131 have a half-life of about 8 days, posing a severe short-term health risk, especially to the thyroid. Medium-lived isotopes like cesium-137 and strontium-90 have half-lives of approximately 30 and 29 years respectively, remaining hazardous for decades as they accumulate in soils, plants, and animal tissues. Plutonium isotopes, particularly plutonium-239, have extraordinarily long half-lives of over 24,000 years, ensuring contamination remains a hazard for thousands of years. In soil, radioactive isotopes can persist dangerously for decades or centuries, particularly plutonium and americium, contaminating food production and ecosystems. Water contamination can similarly persist over extended periods, especially with groundwater contamination from underground tests, posing long-term environmental and public health risks. The lingering radioactive contamination and health impacts from nuclear testing have led to legislative responses, such as the Radiation Exposure Compensation Act, RESA, of 1990. RESA aimed to acknowledge and compensate individuals harmed by radiation exposure, including uranium miners, downwinders, and test site workers. Despite compensation, affected communities continue to advocate for expanded recognition and support due to ongoing health issues and environmental damage. The cessation of U.S. nuclear testing in 1992 coincided with global non-proliferation and arms control efforts, particularly the Comprehensive Nuclear Test Ban Treaty (CTBT) negotiations. Today, remediation and monitoring continue at former test sites, particularly at the Nevada National Security Site and Marshall Islands. Large areas remain restricted due to persistent radioactive contamination, requiring extensive ongoing management to safeguard public health and environmental integrity.